This conference will now be recorded.
All right. So just to recap, yesterday we were talking about something called as RBAC, role-based access control. So typically in a Kubernetes cluster, whatever we are creating, you will have permissions for everything because you will be as an admin where you're modifying or you have the ability to modify everything. So what we have to do is give a role-based access for which we need to first define a role, which will be a combination of what resources and what actions or verbs that it would be associated. And then this role will be binded to a particular service account or a user against whom you will be calling the kubectl or the kube API. Okay. Now, this way, what will happen? We will be actually using a specific user or what we call it as a service account, and whatever the role binding has been done, we would be able to do only those activities. Okay. Now, the next thing what I want to talk is centralized log management. Now, what do you mean by log? So let me first ask a question to everyone. Does everyone understand what do you mean by log or log files? Anyone knows or you guys don't know?
Yes, sir.
Does anyone know what is a log?
Yeah,
Log files.
it's where we get the
Sorry?
Yes, sir.
Yeah, go ahead.
Yeah, generally, so in our project we do server log monitoring. So if any issue comes, so we'll go to the log files. We'll analyze based on log timestamp. So so using log stamp, we will do log analysis using server log files wherever it stores, and also in the Splunk. So using Splunk also.
Okay, that's correct. So in general, now log is nothing but, or what we call it as logging, is nothing but storing all the output, whatever that you are executing as a command or as a script to a file. So that file is what we call it as log file. Now, we saw that when you run CI/CD, you will be getting some output, which is what we call it as console output in Jenkins, right? Now, that is actually a log. So whenever you want, you can go back and have a look at it. So like this, many activities that you do, you will be getting a console output, which if you are interested to store, you will redirect to a file. Redirect means instead of putting it on the standard screen or your standard output, what you can do, you can redirect to a file and you can store all the content into a file, which any point of time you can read. So that's what we ideally do for all your system related information, because if there is a error or there is an issue in your system, how do you go and check? Especially in Linux, there will be certain log files which we refer as kernel logs or system logs, right? So if you go to varlog folder, there will be several files available. Like there is something called as varlog messages, or there will be some files called syslog, or if you try to have some specific output or applications output, then you go and see some logs which are available. So the same way, when we try to run our application, right, our application will also be giving some log. So now the question comes is, when I say log management, if there is any kind of error, we would be interested to go back to that particular file and see at particular time what happened, right? So like this, especially when we are now doing a deployment. What do you mean by a deployment? So the build, whatever we are doing, out of which the application that we generate, we have to run it in some place, and that will be generating some log file. So at any point of time, if I want to debug, I can go there and debug. But now what is happening? So we are not running our application directly. We are using a container to run our application, right? So that way, we also know that Docker gives us an isolated environment, which means whatever we run will be available inside the container. That way, every container has its own file system. Now, what will happen if I say I need 5 replicas of an application? It could be coming up randomly in some machine, and whatever the log files which the application is going to generate, which will be available inside the container only. Okay. Now, what is the concern we have in this? Suppose if I want to do some debugging and I want to see the log files of my container, then how can I get it? Now, typically I have 5 replicas and I don't know where exactly it is running. So I have to go to each of the container and try to get that, correct? Now I can do a Docker logs or a kubectl logs and I'll be able to get that. But think, it is not just one replica that you are having multiple replicas. So I cannot keep running the kubectl logs many times. And the other problem is, what if the pod gets recreated? Then the container also gets recreated, or the container, if it gets recreated, then when you do a kubectl logs, at that time, whatever is the log, you will be getting it. Then whatever the logs you had in the previous container will be gone, correct? So how do I get back everything? Because suddenly for some debugging, you want to see what happened yesterday. Then where are you storing those information? That is when it's more important for us to know how do we manage the logs of our application which is available inside the container. Okay. Now, ideally for this solution, what we have to do is, whatever the log file that we have, because every application will have different types of logs, whether it is the log which your container is trying to put on the containers console. Containers console means when you say kubectl logs, you're directly reading what is the output, right? So that is what we call it as the log on the console of container. However, inside the container also, your application can store some different log files. So regardless of what type of file it is, when you have a log file available inside each container, we have to make sure that you are trying to take the content of all the log files and store it into a centralized location, so that any point of time, if you want some data, you can just go to the centralized place where it will be having all the historical data, whatever that you have stored. So that way, now I don't have to go to each container. Instead, I can just go to the centralized place, for which I will just tell, okay, I want the data from this date to this date, then it will give me everything. So that way, each and every container's data, or each and every container's log, whatever the application is giving, we need to now make sure somehow take the content from each file and store it in a centralized place. Okay, so that is what we want to do. But for this, there are a couple of things we need. Okay, so the first thing what we need is, we need to make sure that we have a centralized location. And second, when I say I want to take the content of a file, it is not that the file will be always static, which means the content in the file will not be the same, because when application keeps running, the file will be getting appended, right? More and more information it will be stored into the file. So when should you read the content from the file? So whenever some content gets added, I should be reading it. So that is where we need another utility which can kind of monitor every file and read data from it more dynamically. That means, have you seen the difference? Like when I say tail-f or kubectl logs-f, it reads data whenever it gets changed. That is what we need. Okay, so what we need to do now is use a utility which will be kind of monitoring all the logs from each and every container available in our cluster of Kubernetes. And whenever some new data has been stored into those files, we need the utility to just quickly read the content of the file and then store it into a centralized place. Okay, so that is where we need two utilities for that. So that's what we are going to do or understand in the log management. Okay, so just to show you, assume that this is what the cluster I was talking about in your Kubernetes, and each machine has its own directory of where-lib, docker, and container. Okay, now what happens when you try to run pods on a particular machine? Then those will be storing all the output about the container information into that specific folder. Now I can do a volume mount and try to read all the log files available from the pod. But ideally, if I try to do a volume mount, and if it is going to be only on the host path, then what will happen? All these things will be stored only into this location. So like this, every machine has its own folder which you will be mounting. So that's where now what we want, if I want some data, instead of me going into each machine, we should be collecting everything and storing into a common location. Okay, so that is what we call it as centralized location. So the same, now if you look, what we will do is we will be now using a utility called FluentD. Okay, now if you're using Kubernetes and reading some logs from the containers or pods of Kubernetes, then this utility is quite popular. Okay, again, this is part of your CNCF foundation. Okay, the cloud native foundation. So FluentD is a utility where now we need to run it on each and every machine of our cluster. Okay, so when you start running FluentD, you can tell what are the logs that the FluentD should be reading it from the pods running on the machine, as well as by default it will be reading all the containers console output also by default. So that way, when you run this Fluent utility on each and every machine on your cluster, whenever a pod comes up, the FluentD will be reading the information from them. So this way, what will happen now, if a container is running, whatever the output that it is giving, FluentD will be able to read each and everything dynamically. Okay, and even if the container goes down and a new container comes up, FluentD will be start reading from it. So this way, regardless of where your container is going to come up or your pod is going to come up, when we have FluentD installed or FluentD running on each and every machine, we will be able to read the data. But it is not just sufficient to read, because we need now a centralized place to store. That is where earlier, we were using database a lot for storing. So the same way, we can also use a database, but ideally storing some data like this into a database will not be an efficient value. So that's where what we need is a better way of storing, which is where what we have called as Elasticsearch, which is again a database, but it's a NoSQL database, which means there is no schema. Everything is more in a plain format, which is easy for us to read or write. Okay, so that's where now we have to use Elasticsearch, which is again another tool to store data. It acts not just as a small, or it's not just a database where you can store, it also acts as a search engine where we can easily query details from it. So that's where now all the data which has been collected by the FluentD, which has been running on every machine, we will try to redirect all of them into Elasticsearch. Okay, so that's where your Elasticsearch acts as your centralized location where all the information will be running. So like this, if I have 10 nodes in my cluster, each node that I have will be having a Fluent D1 running, and that will capture all the information from the pods, whatever that it has been created, and everything will be redirected to Elasticsearch. So that now we have all the information available in the Elasticsearch. Then if a pod goes down and a new pod comes, that will also be stored. So FluentD's responsibility is to collect all the information from this log of the pod and then keep passing it to the Elasticsearch. Okay. Now, again, if you understand, Elasticsearch is more of a NoSQL database where it stores everything. So when you try to read some value from Elasticsearch, it will be giving you more in a JSON output. Okay, so that is where now when I have a huge data to retrieve, you can easily retrieve, or it's very fast to read from Elasticsearch. But when you get the output in a JSON format, again you have to parse it. Parse means you have to split that and try to read exact value whatever you want. So that is where we have a necessity of having another tool which will be helping us to do a quick search and display only the exact values whatever we need. Okay, so that's when there is another utility which will be supporting our log management is Kibana. Okay, now Kibana is a visualization tool. What do you mean by visualization? Now I have so much of data, but out of that, what exactly you want to see, what exactly you want to search, so those kind of things Kibana can help you. Okay, now Kibana is actually a search engine which will help us to quickly search keywords and show the results accordingly. Okay, so now when you try to set up a log management, so you need a combination of all these three, so that the FluentD, which will be running on every machine, will try to read all the information from each and every pod getting created in your cluster in the machine, and that will be stored in Elasticsearch. And as a user, if anyone wants to look into some information or grep some information or query some information, they will just go to Kibana, which will be reading from the Elasticsearch database, and it will be showing you the results. So this combination is what we call it as EFK. Okay, Elasticsearch, FluentD, and Kibana. Okay, now earlier they were using another combination called ELK, where E stands for Elasticsearch, but L stands for Logstash. So there was another utility called Logstash, which will do the same kind of work. But now, since we are focusing more into Kubernetes, okay, so Kubernetes is being backed up by a foundation called Cloud Native Foundation. So the same foundation is the one who has also given FluentD. So it's very easy if you use FluentD within the cluster. So you don't have to do many changes. Okay, so that's where whenever you are using, or whenever you have a requirement where you need to read some logs, then use FluentD within your cluster of Kubernetes. So that's where it's a combination of EFK. So Elasticsearch, FluentD, and Kibana. Okay, so now what we are going to do is we are going to set up EFK installation within our Kubernetes cluster, where again I don't have to set up everything separately, right? So what I can now actually do is find out the images, whatever which is available latest for EFK, and install that itself within our cluster. So it's quite easy for us to manage the installation and configuration. And using this, we will be able to tell Kubernetes how it is going to be collecting information, and we can see. So that way, we are going to use Kubernetes cluster itself to install this, so rather than doing it separately. Like how we had the SonarQube and Artifactory using a Docker image I did. Now I'm going to do the same, but we are not just going to run it on a machine. We are going to run it on your Kubernetes cluster itself. Because now, come back here. So if you look at this instead of me installing an application separately, if I now run a container from a FluentD image, then I'll be having this application. So this is where, how do I make sure that I run this container on each and every machine in my cluster? Then I can define a manifest where I can use it as a daemon set, correct? So if I define it as a daemon set, what will happen? Automatically Kubernetes will make sure that it will be running on every machine which is available. Okay, then that is done. Then if I take Elasticsearch and Kibana, I want to make sure that it is always running. Then I will define it as a deployment object, and for that I will make one replica, so that any point of time if this goes down, Kubernetes will just try to recreate so that will be able to access it. But internally, you also have to make sure that it has a separate volume and you store the data, and whenever it comes back, you will be getting it. Okay, so that's on a wider side that you have to think. But at least in this session, we'll try to focus on how you can set up EFK within your Kubernetes, and how you can make sure that any logs or any pod that is running in your cluster, your FluentD can read, store it into Elasticsearch, and Kibana can actually use to grep, or you can use to see the results. Okay, so that's what we are going to do. But for this, again, we will be using your RBAC. Okay, so that's where we'll now try to see how we will set up each one of them in your cluster, so that how as a deployment object these will be running, and how FluentD will be running as a daemon set. And then once you read the data, how I can see everything which is being read by FluentD stored into Elasticsearch, and I can read from the Kibana. Okay, now this is what I'm going to do. So any questions on this? What is log management, or the diagram or the architecture that I'm showing here?
Yeah, the difference between Elasticsearch and Kibana. The Kibana is a UI things of Elasticsearch. Hello?
Yeah, please tell me, what is it?
Elasticsearch is linked with Kibana. Kibana is the UI things of Elasticsearch.
No, your voice was not clear. I understood you were asking something about Elasticsearch and Kibana. So Kibana will be reading the information from Elasticsearch.
We can get the specific information what we need on UI.
Yes. So Kibana is the UI where it will be having a search engine. You give the query. So based on the query and matching keywords, it will be getting all the information from Elasticsearch, and it will be showing you. So that the users, if they want some information to debug, they can just go to Kibana and search for all the results matching with what you have given, and it will be displaying. Okay, so you don't have to go to Elasticsearch. It's quite easy to just run your keyword search and you can get the output here.
Okay. And the EFK will be set inside a cluster only. We can use EFK inside a cluster for a cluster.
Yes, because now that will be easy for us. If I have to create it separately, then first of all, think how will you install it? Now that is where instead of you installing it separately, if I have a Docker image, it will be easy for me. But if you have it outside, the problems is you do not have any functionality of a pod, right? Because you create a container, it is separate. Who is going to monitor? We have to monitor. But the same thing, if I create it as a pod and put it inside the Kubernetes cluster, then Kubernetes will be monitoring it. So that's how you have a benefit of using Kubernetes. And not just that, when you are trying to have all these things within the Kubernetes cluster, the applications, especially Fluentd and Elasticsearch, can work together. So that is how we will see where I can simply say refer to this in a machine, or when you run it, it will read everything. So that is how typically, if you understand, I need to have my Fluentd running on my container, or I need the Fluentd running on the machine on which my Kubernetes is running. So that way, it's mandatory that your Fluentd is running on the Kubernetes cluster. If you want, you can keep the Elasticsearch and Kibana outside. But if you also keep it inside, it's easy for you to manage and it's easy for giving the connection because everything is within the cluster.
Okay, Fluentd is reading the logs, and it is all Fluentd writing the logs to Elasticsearch.
Correct.
Okay, thank you. More than one number of Fluentd is connected to Elasticsearch. We can connect.
See, it's just a engine, or it's just a utility where it will be reading the information and it will be passing it to Elasticsearch. Okay, so Fluentd will not be like connected to Elasticsearch. It will just read and it will be sharing the information to Elasticsearch, like storing. Okay, it's connected, obviously, yes, but many number of instances connected doesn't matter because it's just going to store the information to Elasticsearch. So that is where if you have 10 machines, then you will be having 10 Fluentds correspondingly connecting to Elasticsearch and passing the information to it. Okay.
Okay.
Okay. So now, so for this, the first thing what I want is, now if you understand, Elasticsearch and Kibana are little heavyweight tools in the sense it needs a little more of RAM that we need to run. Okay, so with my default Minikube, whatever we have taken, my 2 CPUs and 4 GB of RAM will not be sufficient. Even if you had taken a cluster, correct, where the master machine we just used minimum of 4 GB, right? Now, what we will do, we will try to take a new instance where we have little more memory so that my Elasticsearch and my Fluentd and my Kibana should be able to run, at least for you to see how it is running. Okay, so you might have to take a bigger machine. It'll be chargeable now. Okay, but just for practice, make sure that at least you bring it up quickly, test it once, and then you can delete. Okay. So I'm gonna again have a Minikube setup fast, but with a larger machine. Okay, 1, 2, I'll take 18. So I'll take T2 large. Okay, since it's going to be a Minikube, it's okay for me with one machine. And I'll use an existing security group. Okay, I'll just make it as Minikube large. Let's connect. Okay, so there'll be a lot of configuration files that I'll be using, or your manifest files. So I'll share them, but just try to understand the logic, what we are trying to do. Okay. So first, let me install Docker. Okay, so we have to pull back our installation. So we'll install Minikube. Okay, once that's done, we'll install Contract. So okay, so I just made everything separate projects. So this is the project where I have my EFK separated. Okay. So over here, okay, so there are a couple of things that we have to do. So let me first go to README. okay, because there are a lot of steps. So I'll always make sure it's better to follow the steps. Okay, so let's take this. Okay, so now basically what I did is I took Ubuntu 18 or greater and make sure minimum of 8 GB RAM. Okay, now here we need to install Elasticsearch, Kibana, as well as FluentD running. Now, since I took Minikube, I can just run it on only my Minikube machine. Okay, so first what we have to do is I'm going to create a separate namespace which is called as logging, because within that I want to install our applications, whatever we have, and then start reading from it. So that way, first I'm going to create a namespace, and for creating the namespace you will have kubectl create namespace, and the name is logging. Okay, so okay, this is still coming up, let it come. So assume that I have done. The next thing what I'm going to do is I'm going to install Elasticsearch. For installing Elasticsearch, now I have a YAML file. Okay, so if you go back, so now let's read the YAML file one by one. Okay, so over here, now you can see for installing Elasticsearch, I'm defining the object as deployment. Okay, and then the name of it is Elasticsearch. Okay, and if you come down, you can see the spec where I'm giving a match label, and the label name is component and the value is Elasticsearch. Okay, so further down, if you come, I'm trying to define the container, and for the container I'm using Elasticsearch a particular version. So it's going to download it from this specific registry and download
Yeah, Adam, your voice is not audible.
Can you hear me?
Yeah, no. Yeah, it was breaking.
So when you're running Elasticsearch, you need to tell whether to run the Elasticsearch in a single node, or this is a standalone mode, or as a cluster. See, cluster means for high availability, you can have multiple Elasticsearches running and you can connect everything together. Okay, but for us, one single Elasticsearch installation is sufficient. So that's where now I need to pass an environment variable when my container is coming up, and that is what I'm giving it as a single node. Okay, so this is the environment variable. And next, when you run Elasticsearch, it will be running on a port 9200. Okay, now typically this I need to map and then expose it. So that's where first I'm trying to expose from the container level, which is 9200, and followed by that we have resources where I need to tell how much of resources I need to run this. Okay, so you need to now understand for this how many instances of FluentD will be trying to run into it, store the data. So based on the amount of data that you're going to store, the memory is going to change. But this is just for your practice. I'm giving a minimum value. Okay, so that way you can see now I'm trying to specify the request. So whatever that we learned, right? So I'm trying to give for this container what is the request and what is the limit, and in that also I'm specifying both my CPU and my memory. Okay, so this way when my container comes up here, it will be having these values. However, I need to access this. So that's where now if you want to access this, then you need to have a service. So I'm just making sure that I have a service defined, and it also has the same label applied to it so that it knows which pod that it has to monitor. And then I'm trying to define the type as node port so that I'll be able to access Elasticsearch on my machine. That is, it is available outside the cluster. And the port what we have is 9200, which is coming from the container. Okay. So now when you run this, what will happen? You will have a pod running, and that will be having Elasticsearch running that you can access from the node using 9200. And again, it will be created, or it will create a new port on your host machine. That is what is using the service VIP. So you're going to access the service VIP and the port which is mapped to 9200. Okay. So this is what we are going to do. So now let's just make sure it is up. Okay, it's now up, and if you just say kubectl get namespaces, so along with the default and other ones, we don't have our logging, so let us create it first. So let me come back. First, let me say name space is logging. So you have your logging namespace available. Okay. So over here, let's create our Elasticsearch YAML file or the manifest, and let me copy paste this content. Now, what I can do, I can just okay. Okay, once this is done, all I have to do is kubectl apply, and I'm going to say I need to apply it against the logging namespace. Okay, so this is how, if you are using this cluster, right, other users will not be tampering anything with this, because if you have some application to be deployed or roll out, so you will have a separate namespace and you will be defining your object whatever you want inside it. You will not be tampering anything. Now, to cross check, you can just go ahead and now say kubectl get all, and in the namespace called logging. Okay, so you can see this is the particular service running, and if you just go ahead and say kubectl describe service, and the name of it is Elasticsearch, and now you should specify where exactly you want to check. So that is in the namespace called logging. So if I go to my host machine and use the port 31080, so I'll be able to access this. Okay, so that's where your Elasticsearch is up and running. Now to quickly search locally, you can also say curl localhost and the service port whatever is being defined. Okay, so here if I can just go ahead and say, if you get this output,
Adam, voice is not audible now.
Kubernetes will try to
Hello.
Adam, your voice is continuously breaking. Not audible now.
Is it for only you or for others also?
Yeah, for me.
Brothers, for me as
Just
well.
say, madam.
Now your voice is kind of breaking.
Uh, around like last 5 minutes, we're not able to hear you at all.
Is it better now?
Yes, it's good.
Okay. So what I was saying is you just have to make sure that you run the YAML into your namespace called logging so that no other users will be able to tamper it. And if you want to access, you can just access the host machine, and in the host machine, access through the port 3108, so you will be able to use. But we don't want users to directly use the Elasticsearch, because that is where we are going to install Kibana and connect that Kibana to this, and that they can access. So if that is the case, then I should make this as what? Cluster IP, because all of them will be in the same cluster. So Elasticsearch should be read only by Kibana. So I don't need anyone else accessing Elasticsearch outside my cluster. Then I can make it what? By default type, which is cluster IP. Okay, but just to show you, I accessed it. But if not now, understand, I don't want Elasticsearch to be available outside my cluster. Only Kibana needs to be there. So that way, when you're setting up, you need to make sure Elasticsearch should be the default type, which is cluster IP. And Kibana, when we install, we need to make sure it is exposed as a node port, so that is what, as a customer or as an end user, you will be accessing it. Okay. Now, to move further, the next thing what we are going to do is install FluentD. Okay. Now that's where we have to set up the RBAC, because we need permission to read from each of the pod available on the machines. So that way, now first I'll go to a separate file called RBAC. So this is where I have defined a default service account that I'm going to use. Okay. Now just try to understand so that when you try to run it later at your place, you'll be able to go through line by line. So the first one that I'm giving here, I'm defining a service account. Okay. And for that, I'm giving a name. Okay. So this is the service account name called FluentD. So just to make sure everything is the same, right? I'm using the same name, so that now I want this service account to be applicable only under the namespace called Kube System, because this is going to be the management or the administrative namespace. Okay, which is again available by default, and Kubernetes had everything running under this. Even if you go back in the HPA, we had the metric server, correct? So where was that running? It was again running inside your Kube System namespace. Okay, so what we are doing, we are trying to create a service account, and then comes the RBAC. Okay, so in the RBAC, we have two things. One, I have to create the role, and then I have to do a role binding. So over here, I don't want to apply it only to a particular namespace, but I want to apply to the entire cluster. So that's where the kind here is cluster role. If not, if it was specific, then you would just say cluster, only the role. But here I am using cluster role because I'm applying it to the entire cluster. So the API version will be your RBAC authorization. So this is what we just saw yesterday. Now, over this, you can see again, I am having a metadata. I'm just giving some name to this, and look at the rules. So this is where you are trying to tell, when you say a role is nothing but you are going to tell what are the resources or the APIs, along which you have to tell what are the actions or the verbs that you are going to have. So that's where here I'm telling under my API group, I have to give the combination of this. So that way I'm telling resources and verbs. Okay, so what are the resources? So I'm saying for every pod and every namespace available in the cluster, this role should be applicable. Okay, that's what I'm saying. Okay, then when you take a pod or a namespace, what and all permissions that you are trying to give or what commands you can run using this role. So that's where the only thing I'm saying is get, list, and watch. That means I want to just use this role, and this role will be able to get the information from the pods or the namespaces, or read how many pods are available or namespaces are available, and keep monitoring them. This is because the Fluentd that we run, I want to make sure that it knows how many namespaces are there in my cluster, and in every namespace how many new pods are getting created, right? If not, just the normal use case I'm telling, if you type kubectl get pods, what will it show you? Whatever the namespace you are running, it will show. But if I had 5 namespaces in my cluster, how can I read that? That is where I need to first know how many namespaces are there, and inside the namespaces how many pods are there. So that is what we are trying to say as a role, wherein we would have the list of pods and the namespace available, and we can read from that. That's the only thing I want with this role. So this role doesn't want anything else to do, just to read. Okay. And then if you come down, we are doing the role binding. So in the role binding, what we are doing, so I'm trying to tell the name of the role. Okay, so that's where you might be thinking why everywhere Fluentd is there. It's just for understanding. We are just using this name everywhere, the common, because if not, you can give whatever the name that you have and the name here. But just to make sure that everything is same, we are referring to Fluentd. So over here, we are trying to tell and against which subject you have to apply. So this is what our role binding is. So for this, I'm trying to tell the service account name, which is available specifically in this namespace. So that way, now when I'm going to run my pods, we will use this service account name. Okay, and that will be allowing us to have the role where I can go to all the namespaces and I can read the pod information, namespace information, which is what the Fluentd will be requiring. Okay, so for that we are trying to pass this. Getting it? So this way, when we run RBAC, when we implement this RBAC, and when we have the Fluentd setting up, we will be using this so that it will be able to read all the namespaces and the pods in our cluster. Okay, so that's how in every machine it will be able to read. Okay, getting it? Your role and role binding, and for that we had the subject or the service account created. So we mapped the 3. So now if you go back, okay, so you have the Fluent YAML. Okay, so here if you just look, I'm using daemon set. That is because I want to make sure that the Fluentd container or pod is running on every machine. Okay, and then further I'm just defining metadata. Okay, and this is where again I'm saying to run it under kubesystem, and I'm trying to use some labels. Okay, it's again no meaning of this, but it's just for our understanding, we are using the label. Then come down, so you will say for matching your daemon set what label that you're going to take, and then further the template of your pod where again you're using the same label. But the actual thing is now you need to look into this. Okay, where I'm now telling use the service account. Okay, so that means when Kubernetes is going to create this pod and run, it will be running using this service account. So whatever the application which is running here, it will have access to the role that we had, and corresponding the role binding, it will be allowing us to get the details of the pods and namespace within this. So that is how internally the Fluentd will also be able to run those commands and get the information. Okay, so we don't have to run and pass the information. this will be able to do. That is where we are creating a role and passing it. And what is this keyword called toleration? Now, are we going to run our pod on the master? Typically, no. So if you take a real cluster, what will happen? You will be running it only on the worker nodes, right? So that way, do you want the Fluent to also run on the master? Okay. So that is what I'm saying. Don't run it on the master, only on the worker node. You go ahead and run. Suppose if you try to set this in an actual cluster, and if you have 4 worker nodes, 4 Fluentd replicas will be there. It will not be running on the master. So that is what we are trying to tell, not to run this pod on the master. Okay. And after that, we are trying to define our container. Okay. And this is where we are using a particular image from which I will have my Fluentd application up and running. Okay. Now, when I'm specifying my image, I need to tell to Fluentd where to connect. So that's where we have certain environment variables defined, where you can see I'm telling where is your Elasticsearch available. Now this is important. Pay notice here. So I'm trying to tell the Elasticsearch is accessible using your service name dot namespace, because understand this, Fluentd is going to run in a namespace called kubesystem, and Elasticsearch is running under logging namespace. So that is how, if you had mentioned it as a cluster IP, suppose, and if you want to access, then I don't want Fluentd to access somewhere outside. It is inside the same cluster, right? Then if you just say the service name of Elasticsearch dot the namespace under which it is running, then Fluentd can directly connect to Elasticsearch. So that's where the name of the service is Elasticsearch again. That's where, just to keep it simple, if you come down, you will know this. So what is the name of the service? The name of the service is also Elasticsearch. Okay, so that's where, if I now say Elasticsearch.logging, this is the namespace in which you will be able to directly access the Elasticsearch available, okay, as a service. But for a service, we have a port number. So that is what we are defining using next variable. Okay, so this is how, now by giving these variable, Fluentd will be able to connect to Elasticsearch, or every replica of Fluentd will be connecting to the same Elasticsearch running inside your cluster. Okay, so by this you will have the connection from the Fluentd to Elasticsearch. And if you come down further, this is where I need the resources for running my Fluentd pod. Okay, so I'm just trying to tell a minimum and maximum that I need. Again, this would change in your production, but for just testing purpose, I'm giving a minimal value. Okay, then the next one is, when Fluentd is reading, how will Fluentd read the information? Because Fluentd will not be going inside the pod. So now, if Fluentd has to read the information, this is where we need to make sure that whatever the application or container we are running, right, all of them will be mounting to some file or folder on your host machine, which the Fluentd can read. So that is where here, what I'm trying to tell, that if you go back, when I was defining my CI/CD, and in the CI/CD, in the application image that I was creating, I typically mentioned that whatever the application log is available, it should be putting into a folder called where_log on the host machine. So that way, if I go to the host machine, I can read my applications log from where_log. That is what I'm giving it as a mount path to my Fluentd. As well as we are also telling to read from the where_lib docker containers folder, so that whatever the container or the pod that is running on that machine, if there is a console log available that is like doing a kubectl logs-f, that it will be reading here. Okay, so now Fluentd will be trying to read from these two locations. One is whatever is available on the console log of each of the container, it will read from this location, as well as if there is any specific file from which you want to read, then you have to give that, because for this you need to make sure that your application is mounting a folder to the host machine, that is through your pod, and that you are trying to read through Fluent. So this way Fluent will make sure that it is trying to read these two continuously. Okay, so that's where, now try to understand, this is your volume mount inside your container, because once again, where is FluentD running? Fluent is running inside a container. So can it access the host machine folder? No. That's where we are trying to actually set the volume. So what it means now is the where-lib Docker container of your host machine will get mounted inside the container as where-lib Docker container. Same way, from the host machine, the where-log folder will be getting mounted into where-log, so that the naming convention are same. Because when you run FluentD, FluentD will search for this. So this is how we are trying to say host path, and we are mounting it to the host machine to container. So now when FluentD pod comes up, inside the FluentD container, you will be having these two folders. Now what are these? These are nothing but volume mapping available from the host machine. So this is how FluentD will be able to read the information from all the pods running on your current host machine. Okay, so now for this, let us go back and now first try to create this, and we'll apply one by one. Got disconnected. So let me just copy paste everything first. So here I'll create another file. It's not copied. Okay, so I have these two. So what I have to do now is, first we need to apply the RBAC.YAML so that it will create the service account, and the role binding will be done. Okay, so you can see service account, role, and role binding has been done. Next, we'll go ahead and apply our FluentD YAML. Now, since it's Minikube, it will be running only on this machine, but if you have an actual cluster, it will make sure you have a copy of your pod running on all the machines. Then let's cross-check by executing kubectl get pods, and now your Fluent pod will be running on kubesystem namespace. Okay, so you can see this has started running. Now here, this is just one machine, so we are just trying to see it on the Minikube on the first machine itself. Okay, because we don't have many machines. Then now, for us to make sure that the FluentD has been connected to Elasticsearch, which is running, that's the reason I said keep everything in the same cluster. So if you go ahead and now say kubectl logs-f, and this is your pod, okay, and this is available under your kube system. Okay, so you'll be having a lot of output, but from this, search for connection opened to Elasticsearch. Okay, so just check whether this is available. If this is available, then it means your FluentD is connected to Elasticsearch. Okay, you can see. So Elasticsearch is being found, and the FluentD is connected to this location. So instead of giving it as a URL, you are giving it as the service name, because internally service name will be allowing you to map the IP or the VIP, and then .logging is the namespace, and in that you have 9200. So it's trying to detect, and you can see it's connected. So this way your FluentD is connected to Elasticsearch. Now we have just one connection because one machine. So that's where in this machine FluentD is running and it is able to connect to Elasticsearch running. So like this, if you have multiple machines and if you go to each machine and see the replica and check the logs of the FluentD, you should be able to get the information whether it's connected or not. Okay. Now this is connected. So the next thing what we are going to do is just install our Kibana. That is the only thing pending. Okay. Now for that, the last one that we have is kibana.yaml. So once again, if you come, I'm defining it as a deployment object. Okay. And I'm giving the name of this is Kibana. And we are using a label where the name of the label is run Kibana. This is for your spec of the deployment object. And then further, we are trying to define the template of the pod because I'm giving it as deployment. So here, under the container, I'm trying to use a specific version of Kibana, which is 654. And once again, for Kibana, you need to tell where is your Elasticsearch, right? Because Kibana should be connecting to Elasticsearch to read the information. So the same way, when you are starting Kibana, you need to mention a details. So that way, again, I'm passing it as a environment variable, and I'm telling this is my IP, wherein Elasticsearch is nothing but your service name, because which is available in the same cluster, and that access through 9200. Okay, so you're not accessing it outside the cluster, so that way within the cluster you are directly able to access using the service name and the IP which the pod is exposing. And then when you run Kibana, Kibana is also a web application, so you need a port that it will be exposing. So that is 5601. So this is Kibana's port. Okay, and further, if you come down, I'm trying to define a service which is of the type node port, which will be allowing us to access Kibana. So this way, now FluentD has connected to Elasticsearch, and now your Kibana will also connect to Elasticsearch, so that any information that FluentD is storing into Elasticsearch, we will be able to grep it from our Kibana. Okay, so the last thing that we are going to do is define this. Okay, so now all I have to do is run it. So that way, again, I'm going to run Kibana on the logging namespace. That is the reason, if you look now, I mentioned the location of Elasticsearch was just the service name, because for FluentD to connect, I had mentioned service name dot namespace. But now for Kibana, you don't need it. We just told the service name dot the port number. Why? Because both the Kibana as well as Elasticsearch is available within the same namespace called logging. Okay. Hmm. Okay, that's because it's not YAML, it's YAML. Okay. So now we have this up and running. To cross check, you can go back and say get pods under your logging and see what is happening. So you have your Kibana, it's still trying to come up. Okay, now this is where the memory utilization will be quite high. So what I can do, I can just free up some memory. Okay. The buffer, whatever it has taken, right? Let me free up. So I have everything. So let's wait for Kibana to come up. So you can see Kibana started up and running. So now your Kibana is also up and running. So to start accessing, you can go to the host machine's IP and use the exposed port, whatever is coming from the service VIP. Okay. So here, what I can do, get all. So this will tell me the service name. So the name of the service is Kibana. So here I'll say kubectl describe and service name -n logging. So the port number which Kibana is exposed is 3026. So I don't have to access using 5601. So let's go back to our AWS, and here I'll try to add in the inbound rule of the security group. Inbound rule. Okay, so over here, what is the port? 30026. Okay, so I'll just change one. 30026. Okay, so now if I want to access, I can just take the IP or the DNS, and over here, if I say colon and the port that has been exposed, which is nothing but your 30026. Okay, so now you can see it's connecting to Kibana. So this way, what we have done, we have set up Elasticsearch, Fluentd, and Kibana on your Kubernetes cluster, and all the information what your pod will be running will be collected by Fluentd. It will store into Elasticsearch, and you're going to access. So this is where, if you have developer or QA or some customers that you want to see information about log, they don't have to go to the cluster or they don't have to access the Elasticsearch. They can just come here, and using this, they'll be able to see the metrics, they'll be able to see the logs, use some keywords to search, so that it's easy for them to manage only this. So they don't need access for your Elasticsearch. Okay, so this is where right now we don't have any data that is being collected. So what we will do for this, now let us have some pod, and we will run some pod, a test pod, and using that, we'll be able to see what information that we are trying to capture. Okay, so that's what we are going to do. So for this, let me go back to my cluster. Okay, now let's quickly define one pod, just a test pod. So let's take this example what we had. Okay, so here, rather than just printing my name, so what we'll do, okay, I'll also add today's date so that we also get the time. Okay, now just to show you, if I run this, where's the syntax error? Oh, okay, so okay, so instead of just running this, whatever the default that you have, you will see that it's at least trying to print the details one by one, correct? So that you will know what exactly it is running. All right. This is weird because It's not changing the value of date. Okay, probably we'll run it inside and see. Anyway, I'm just going to print it so that you will at least see that it's running. Okay, so now let's take this example. Okay, and let's run this from our cluster. So I'm just making it as testpod.yaml. Okay, so let's just go ahead and say kubectl apply -f testpod. Okay, and if I say kubectl logs -f testpod, yeah, now it is printing properly. So you can see 11 second, and after 5 seconds is 16, and then 21, 26. Anyway, now this is what I want the Fluentd to capture and store it into Elasticsearch, and using Kibana I should be able to read it. Okay, now what we have to do is we need to go back to our Elasticsearch cross-check, or we can directly go to Kibana and we can cross-check. Okay, so this is where now go to Kibana, okay, and try to create a new index pattern. So let's go back. Okay, now over here you can go to Discover. Okay, and in the Discover you can see we are going to create a new pattern. Now over here, now in the index pattern, the name of the information, whatever it is stored by Fluentd, right, it will be storing it as logstash only. Okay, it's the name what it is going to refer. So that way what we have to do is create an index pattern by saying logstash star. Okay, so whatever that we are trying to read from that, Fluentd will be storing it as an index. Index is nothing like a you can consider like a table in your normal database. In Elasticsearch, it is going to store under this name. It's not exactly a database, you can consider it as a table. Okay, so this is the table in which the information is stored, but we don't call it as a table in Elasticsearch. Okay, so now put it up here. So you can see it says there is one index which is matching, because that is what Fluentd has started storing into your Elasticsearch. Now over here, what you have to do is use the timestamp, because I'm trying to refer everything based on timestamp, and click on create index. Okay, so over here it's trying to show a couple of data. So that's where what we have to now do is, once it is done, okay, now go to Discover and try to again search with this pod name. Okay, so now if I go back, right, so I have an index that is created, and you can actually see it started collecting all the information. You can look down, it started already collecting, but it's showing everything, right, because there are many pods that is running, so it is trying to get all the details from all the pods. But I'm not interested in everything else, so now I can query by saying what exactly you want. So what I want is to read only from a pod whose name is test pod. So you can see this is what we had created. So if you want to look from there, then this is the search engine where you can typically tell by saying what are the information that you want. So over here I can add a filter, or that is how the key search will work. I can go ahead and say kubernetes.pod name. Okay, so I'm just going to say pod name, and here what is that mapping that you have to do. So once again, here the test pod is what we are running, so just go ahead and say my pod name is what is the value that you want to give. Okay, so this way it will search for a particular pod and give. If you don't give it, then it will try to read all the pods which is available or which has been stored into Elasticsearch, matching this name it will give you. But here I'm saying search for a property called Kubernetes pod name, and in that I need to make sure that if the pod name is test pod, and then give me those data. Okay, so you can see here now the log got refreshed, and now it is trying to show you only that logs. So it's not showing all the other logs. Whatever is coming from my actual pod, that's what is being printed here. Okay, so this is how you will be able to get all the information available, and it's quite easy for a user to only search for the related items. He doesn't have to search for many things. So this way, if you have multiple applications and different pods running, the user can easily kind of use a combination of search pattern, and he can exactly search what pod he wants, in that what log is coming, or further he can use some complex query to read for a particular line or a string in the output also. So that's how Kibana is more powerful for your search engine. Okay, so this way you can see our responsibility will be able to make sure that the logs are being read from each and every pod through Fluentd and store into Elasticsearch, and that's been connected to Kibana where the users can refer to this. Okay, getting it how EFK is working?
Yes, sir.
Yes, Adam.
Okay, so this is what we did. Now, just for understanding, we took all the minimum values and we have set up. Again, remember, we had a separate namespace for running Elasticsearch and Kibana, and that's where pay attention to all those whatever I have mentioned. How Kibana connected to Elasticsearch using the service name. Same way how Fluentd connected to Elasticsearch, because now Fluentd was running in a different namespace. So to connect, again, you are using the service name dot the namespace. And then ideally, when you run Fluentd, it's not just about reading, but it needs to read by having a proper access. So that is where we introduced RBAC, and that RBAC will help a role and a role binding for Fluentd, and that's where the service account was mapped. So using the service account, when you run it, the Fluentd will be able to read the information from all the pods running on the particular namespace in the machine. Okay. But you can also use it for various purposes. Like for example, let's say you don't need Fluentd, but for system logs, like someone was telling. So if you want to have, yeah, forget about Kubernetes for some time, but you can have a Elasticsearch and Kibana, and you can use Logstash or some other similar tool to read the logs from your kernel for every machine that you have, and then store it into Elasticsearch. So that later point, if you want to grep, it'll be quite easy for you to search through Kibana. Okay.